So the first thing we have to learn, we will use the matrix to convert a system. System, how it look like the system. So if you have negative x plus y equal 8. We already know this is a linear equations with two variables, x and y. So this is linear equations with two variables, x and y. So what about if we have two linear equations? Like two linear equations, here's another one, 7x plus or minus, let's do it minus, 4y equal 7. Two linear equations with two variables. We will call this one a system. Why we call it a system? Because we have two linear equations with two variables, x and y. So we call this one a system. Now, the first thing, we already know what's the meaning of the system. If you have more than one equation at the same time, like this one, we can't solve this one by itself. We can't solve this one by itself. We have to solve these together. So there's many methods. Like there's two methods to solve a system. One of these methods is the matrix. But the first thing we have to learn how to convert the system to a matrix. So this is the system. I need to convert this system to a matrix. We called it augmented matrix. So here is the second thing to write, how to write, which is easy. The augmented matrix. Because they're gonna ask you about that. Write down the augmented matrix. How are we gonna write down the system to a matrix? The system, the first thing you have to check the system. All the variables on one side, here's the equal sign, and all the numbers on the other side. Like move the number to just number by itself. If you have a number here, you're gonna move it to the other side. So this is the first step. I have to check it with the system and check the variables x, x, y, y, x, x, y, y, and the numbers on the other side. That means this system is ready. How to convert this system to the matrix? You're just gonna open two large bracket. You see the line here? The line here is the equal sign. The line here is exactly the equal sign. Now I'm going to write down, take from this system only the coefficients. The coefficient here, negative x, that's mean negative invisible one, x. So I'm gonna write down -1. The coefficient here is 7. I'm going to write down the 7 here. The coefficient here, there is no number, that's mean invisible 1, so I'm going to write down the 1. The coefficient here is -4, so I'm going to write down -4. Here's the equal sign, 8, 7. Here the 8, and here's the 7. So you see, this is the matrix. We call this matrix augmented matrix. And this is the method to convert the system to augmented matrix. The first step, you have to make sure all the numbers to the other side from the equal sign. Make sure x, the variables on one side, on one column. This is the variable x. Here's the variable y. Now let's go to the matrix here. We call this one row 1. You see, this is the row 1. Here we call it row 2. This is row 1, this is row 2. We call this one here column 1. We call this one column 2. And this one column 3. Row 1, row 2, column 1, column 2, column 3. We're not gonna study higher than this. We're just gonna study 2 rows and 3 columns. So if they ask you, this is how it looks like the augmented matrix. If I telling you row 1, that's mean this one. Row 2, that's mean this one. Column 1, column 2, column 3. The next step, I'm going to take another example about that. If they ask you about the size of the matrix. If they ask you about the size or the degree of the matrix, but the main thing, the size, that means how many rows and how many columns. So the size, always you're going to write down the rows first, the number of the row times the number of the column. And you're not going to multiply it. Like for example, for this one, I have 2 rows. So I'm gonna write down 2 times how many columns? 1, 2, 3. So this is the size. This is the size of the matrix. And they're going to write down the size as a small 2 numbers here. That means this one is going to be -1, 1, 7, 4, 8, 7. This is the augmented matrix. And you see the size, they're going to write down a small numbers here, 2 times 3. That means 2 rows, 3 columns. So always when they ask you about the size, be careful here, always 2 rows and 3 columns. The rows first, then the columns. 2 rows and 3 columns. This is the size of the matrix. We're going to do another example about how to write down the augmented matrix.
Sir, what about the sign of the -4?
Oh yeah, you're right. I just forgot the sign. So it's -4, supposed to be -4. Perfect. -1, 1, 8, 7, -4, and 7, yes. If you have any questions about this one, you can ask before we move on to the next example. So let's do another example to write down the augmented matrix. So here's the system. We have -5x plus 6y equals 7. And the other, we have 4x minus y plus 6 equal 0. So here is the system. This is the system, 2 linear equations with 2 variables, x and y. I have to make sure the first step before I'm writing down the augmented matrix, x, x, y, y, but I have a number here before the equal sign. So I have to move this number to the other side. So if you see here, the first equations here, we have -5x plus 6y equals 7. Everything is okay with the first one. The variables here on one side and the number by itself to the other side. With the second one, I have to move the 6 to this side. So I'm going to say -6 from both sides. So it's going to be 4x minus y equal -6, because this cancel is going to be negative. You see now the second equations. The second equations here is going to be 4x minus y equal -6. Now here is the system. I already convert this number to the other side. How? By -6 from both sides. So I have now the x here, the y here, and the number by itself on the other side. So now the system is ready. I can write down the augmented matrix. Open two brackets. And here is the equal sign. The coefficient here, -5 and 6. And the number here is 7. 4, -1, and -6. So this is the augmented matrix for this example. Let's write down the size. Row times column. How many rows? 1, 2. So 2 rows times 1, 2, 3, 3 columns. So the size here is 2 times 3. That means two rows and 3 columns. So the next example, write down the system. That means they're going to give you the matrix and you have to write down the system. Like 18, 6, 10, 13, 6, another 13. Always keep in your mind, so here's the augmented matrix. I need to write down the system. By the way, you can choose any two variables, x, y, u, v, it doesn't matter. But the main thing, you're going to choose the same variables for both equations. So let's choose the x, y. And when you're doing the homework on my lab math, they're going to tell you, maybe they're going to tell you choose x and y as the variables. So choose x and y. So always here's the x. This is, I'm going to do the y here, and the number by itself is going to be on the other side. And here's the equal sign. So it's going to be 18x plus 6y equal 6. Let's do this one, -10. This is the first one. The second one for the system is going to be -x, -10x. They have -10 plus 13y equal 13. So now this is the system for this augmented matrix. Here's another one. If we have this augmented matrix, which is -5, -6. So be careful with the matrix with the sign. 8, -2. So they give you the augmented matrix, and you have to write down the system. 4. So this is the augmented matrix. The size for this augmented matrix, 2 rows, 3 columns. So 2 times 3. To write down the system, I'm going to choose the x and y. Here is going to be the x, here is the y, and the number by itself is going to be on the other side. So it's going to be -5x minus 6y is going to be equal -5. And the second one is going to be 8x minus 2y is going to be equal, the number is going to be 4. So here is the system. This is the augmented matrix, and we're going to write down the system. It's going to be easier because you just have to write down exactly the same thing. Choose the same variable, x, y, negative 5x minus 6y. Here is the equal sign, negative 5. 8x minus 2y. And here is the equal sign 4. And so for this augmented matrix, here is the system. Row transformation, we're going to use the row transformation when we're trying to find the solution for the system by using the matrix. So the first thing I need you to know, because we're going to use these steps, when we're going to write down the small r, that's mean the old row for the matrix. And when we need to write down, find the new row, so we're going to write down capital row. Capital R, that's mean this is the new row. So that's mean R1, which is old R1, R2, old row 2. Capital R1, which is a new row 1, capital R2, a new row 2. So this one is going to be new row 2. This sorry, new one, row 1 here, and the new row 2. This one is going to be old R row 1, and this one is going to be old row 2. So you have to know these. It's not that much hard. This is the old row. This is the new row. Old row 1, old R2, a new row 1, a new row 2. For example, let's do an example about how to use the row transformation. So for example, if you have this augmented matrix with 2, 3, 8, 5, and here's the 4, 3. Here is the augmented matrix. They're going to tell you, which is, I call it the rule. We're going to use this rule. I need you to change or to get a new row 2. So here's the matrix. They're telling you, I need to get a new or change the row 2. Get a new row 2. How? By multiplying negative 4 by the old R1. So now I need you to get a new row 2. How are we going to get a new row 2? By multiplying negative 4 by the old R1. Let's do this. Here's the rule. I'm just going to use this rule here exactly. Now, here is the matrix, the new matrix. I'm going to get a new R2. That's mean the old R1 is going to be exactly the same, which is 2, 3, and 4. And I'm going to get a new R1, new R2. This is the old R1. This is the old R2. I'm going to get a new R2 here. Let's start using this rule. The first number is going to be negative 4 times the old R1. Here's the old R1. This is the first number. So negative 4 times 2 is going to be negative 8. So here is the first number with the row 2. I'm going to write down negative 8 here. I'm not going to care about this one, the old R1, because they're telling me to get a new R2. The second one is negative 4 times this number, which is 3. So it's going to be negative 12. So I'm going to write down here negative 12. The new R2, you see, we have to do one more step. The new R2 is going to be negative 4 times R1, which is the last number of R1, 4. So it's going to be negative 16. So now negative 16 here. You see, we got a new R2. How? By using this rule. I used this rule to get a new R2. How? By multiplying negative 4 by each number in row 1, because they're telling me you're going to get a new R2 by multiplying negative 4 by the old R1. So I'm going to multiply negative 4 here to get negative 8, negative 4 here to get negative 12, and negative 4 by 4 to get negative 16. So here's the new matrix with the new R2.
Is the negative 4 part of the rule, or did you get that out of the what was in the matrix?
No, negative 4 here.
This is part of the rule, yeah.
This is the part of the rule.
Okay.
Now let's work on row 2. Let's do this all. We need to get a new R1. How we will get a new R1? By multiplying negative 2, this is the rule, by R1 and add to the R2. Now this is the rule. I need to get a new R1. How? By multiplying negative 2 by the old R1 and add it to the row 2. Let's do this one. That's mean, here's the new matrix. I'm going to get a new row 1. That's mean row 2 is going to be exactly the same. This is R1. This is R2. So R2 is going to be exactly the same. There is no change. It's going to be on R2 because I'm going to get a new row 1. Let's start with the first number. Here's the first R1. I'm going to multiply negative 2 times the first number here with the row 1 is 2. Negative 2 times 2 plus the first number with row 2 is 8. Negative 2 times 2 is going to be negative 4. Negative 4 plus 8 is going to be 4. So the first number here is going to be 4. Let's do with the second number. To get the second number with the new R1 is going to be negative 2 times the second number with row 1 is a 3 plus the second number on row 2 is 5. So negative 2 times 3 is going to be negative 6. Negative 6 plus 5 is going to be negative 1. So the second number here with the new R1 is going to be negative 1. Now, the last number on the new R1 is going to be negative 2 times 4 plus 3. You see, I'm using the rule, negative 2 times 4 plus 3. So negative 2 times 4 is going to be negative 8. Negative 8 plus 3 is going to be negative 5. So here is negative 5. So we get a new R1. How we get a new R1? By using this rule. So here's the rule. R2, the new R2 is going to be negative 3 times R1 plus R2. So I'm going to get the new matrix here. I'm going to get a new R2. That's mean the old R1 is not going to change. And here's R2. So it's going to be 2, 3, and 4. Let's use this rule. The first number is going to be -3 times R1, which is the 2, or we can use this 2, the same thing, plus R2, which is the 8. -3 times times 2 is going to be -6, plus 8 is going to be 2. That means the first number is going to be here 2, which is the new R2. The second one is going to be -3 times 3 plus 5. So it's going to, you see, I'm following the rule. Plus 5. So -3 times 3 is going to be -9. -9 plus 5 is going to be -4. So here's the second number here is -4. The third one is going to be -3 times 4 plus 3. -3 times 4 is going to be -12. -12 plus 3 is going to be -9. So it's going to be -9. You see, the old R1 is going to be exactly the same thing because we need to get a new R2, and here is the new R2 by using this rule. This is how we're going to use the row transformation when we're trying to find the solution for the system or for the augmented matrix. Let's do another example about that. 2 more examples, because this is really important before we
Sure.
start finding the solution. Go ahead.
I'm sorry. So the solution, it will be 2 minus 4 equal -9.
Which one are you talking about?
The solution, or on the homework, what are we going to write?
On the home, this is now, until now, we're just using the row transformation. So if they ask you, this is the matrix, and use this rule to find the solution. So here is the solution until now, because we need to get a new matrix. How are we gonna get the new matrix? By getting new row 2. That means here's the solution. Okay? 2, you see the change, the difference between these two matrices? 2, 3, 4, which is the old R1. We get a new row 2 by doing these steps. The new R2 is 2, -4, and -9. So until now, this is just using the row transformation, which is, this is one of the rule row transformation, this one. That's mean they're gonna give you this one, and they're telling you use this row transformation to get the new matrix. Okay? I'm using the same matrix. 2, 3, 8, 5, 4, 3. So they give you this matrix. And now they're telling you, I need you to get a new R1. This is the old R1. This is the old R2. I need to get a new R1. How are we gonna get a new R1? 2 times R2 plus 4. So here's the rule to get the new R1. You see, this is the equations. This is the matrix. I need you to get a new R1 by using this rule. So the solution is going to be here. I'm going to get a new R1. That means R2 is going to be exactly the same. 8, 5, 3. Because I'm going to get a new R1 is going to be here. Let's use this rule. R1 is going to be 2 times R2 is 8 plus 4. 2 times 8, 16. 16 plus 4 is going to be 20. Two times 8 plus 4, I'm using this rule. 2 times R2 plus 4 is going to be 20. So write down 20 here. The second one, 2 times R2 is 5 plus 4. So 2 times 5 is going to be 10. 10 plus 4 is going to be 14. That means here is the second number here. R1, the last one, is going to be 2 times 3 plus 4. 2 times 3 is going to be 6. 6 plus 4 is going to be 10. So you see, this is the solution. I got a new R1 by using this rule. So the new matrix is going to be here. Here's the new R1, and here's exactly the same R2. That's it for this example. The last example on this part we're going to do, I'm going to use exactly the same matrix. 2, 3, 8, 5, and 4, 3. This is old R1, this is old R2. We want to do exactly the same thing, but now here is the rule. It says get a new R2. How? By using the old R2 divide by 2. We're going to use the old R2 now, divide by 2. That means the new matrix is going to be like this. 2, 3, 4, because I'm going to get a new R2, which is going to be here. How I'm going to get the new R2? By dividing the old one by 2. So here's the first one. I'm going to divide the old R2, which is the first number here is 8. So 8 divided by 2 is going to be 4. That means the first number here is 4. Now the second number is 5. So here is the second one. It's going to be 5 divided by 2. 5 divided by 2 is going to be decimal number. So we just going to write down 5 over 2. It's going to be fine because 5 over 2 is fraction. I don't have to convert it to a decimal number. So just write it down as a fraction. The last number is going to be 3 R2 divided by 2. So it's going to be 3 divided by 2. Also 3 divided by 2 is a decimal number. So I don't have to write a fraction. I don't have to write down as a decimal number. So I'm just going to write down 3 divided by 2. So here is the new matrix. How I get the new matrix? Because they asked me to get a new row 2. How? By dividing the old one by 2. And here's the new matrix. So the method to find the solution for the matrix or any system is called Gauss. To find the solution for the system, but by using the matrix. Gauss-Jordan method. And they're going to tell you, because there's another method, but they're going to tell you use Gauss-Jordan method to find the solution. So the first thing about, after they're going to give you the system, then the next step, you have to write down the augmented matrix. Then how we going to use the Gauss-Jordan method? Like for example, if we have this matrix, like -5, -3, 6, 1, and here is 4, 2. So here is the matrix, and they ask you to use Gauss-Jordan method to find the solution for this system or for this augmented matrix. So my goal is to find the solution. How? By converting this number to 1. This is the first step. This number to 1. I'm going to convert this number to 1. How? By divide. And I'm going to show you. Then the next step, step 2, convert this number to 0. Convert this number to 1, then convert this number to 0. Then this is step 1 here. Step 2 is going to be here. Like walking from this one to this one. Step 3 to this number. Let's change this number.
Sir, the -5, we're gonna divide it into what?
I'm going to show you. We're going to do an example so you will know we're going to divide by what. But the main thing, divide. You're not going to divide here. Step 2. Step 3 is also divide. Okay? So this is step 3. I'm going to give you the map. Here's step 1. You're going to go to step 2. Step 3 is divide. Step 4, which is here, is not divide. This is the last step. From here, let's go here. So here is the map. We're going to start from step 1, which is divide. Step 2, let's do add. Okay? Step 3, divide. Step 4, you're going to add. I'm going to show you. Then our goal, step 1, when we divide, we're going to convert this number to 1. Step 2, when we add, we have to convert this number to 0. Step 3, we're going to divide. We're going to convert the 5 here to 1. Step 4, we're going to add. We're going to convert this number to 0. You see these two numbers? I'm going to get new numbers here. These two new numbers is going to be the solution. Let's, for example, say here 5 or 1, and here is 0. Let's do 2. Like after do this operation, I got 1 and 2. That means I'm just going to write down x equal 1 and y equal 2. Is going to be the solution for this system. Again, we have to know the steps. This is the map, and I'm going to do each step with details, so you will learn how we're going to work on it. This is the map. This is really important. The first step here, you're going to divide. The second step here, you're going to add. The third step, you're going to divide. The fourth step, you're going to add. Here is the other map. When we divide, we have to convert the -5 to 0. When we're going to step 2, when we're going to add, we have to convert this number to 0. So the first one to 1. The second number to 0. The third step, we're going to divide. So we're going to convert the 5 to 1. The last step is step 4, we have to convert this number to 0. These, we will see there's new numbers is going to be here. 4 is converted to 1. 2 is converted to 2, or let's do it another number like 3. For example, this is a 3, so you're not gonna confuse. You see the number here is a 3 converted to 2. That means my solutions is going to be x equal 1 and y equal 2. Let's do an example about that, and I'm gonna do the steps here, each one, and always you're gonna do exactly the same steps. Always you're gonna do exactly the same steps. There's a simple example about that. If we have this matrix, I'm going to use another paper because I need to write down all the details. But I need you to write down this map before we start the example, because we're going to do exactly the same on the map. So here's the example. We need to find the solution for this matrix, which is -1, 2, 3, -4, and here is -6, and here is 14. So I need to find a solution for this matrix. Sorry. Step 1, it says divide. Check what's the meaning of divide. If you're doing these steps all the time, you're not going to do mistakes. For the matrix, take your time. So divide. I need to convert my first step, convert this number to 1. Convert any number here to 1. So convert this number to 1. So I'm going to divide. I need to get a new R1 because I'm going to do a change on the row 1. I'm going to do R1, the old one, the old R1, divide. How I'm going to convert -1 to 1? I'm going to divide it by 1. -1, divide by -1 is going to be 1. So I'm going to divide by exactly the same number here, by -1. If you have 6, -6, you're going to divide by -6. If you have million here, you're going to divide by million. So you're going to divide always these two numbers, the division step 1 and 3, you're going to divide exactly by the same number, but you're going to divide the whole row, the whole R1. Because when you're doing change in one element, you have to do the change for all the elements at row 1. So divide this number by, this is my goal, convert this number to 1. How? By dividing the whole row by -1. So a -1 divide by -1 is going to be 1. 2 divide by -1 is going to be -2. -6 divide by -1 is going to be 6. So this is the first step. I'm not going to do any change on row 2, so I have to write down exactly the same R2. 3, -4, and 14. You see the first step here, step 1, convert this number to 1, any number here to 1. So I'm converting any number here to 1. This is my first step to find the solution, which is divide. So I'm going to divide any number exists here by exactly the same number, but I have to divide the whole row by exactly the same number here to convert it to 1. This is step 1. Step 2, add. I'm going to write down this matrix again here. So I'm not going to do any mistakes. I'm going to write down this matrix again here. This is step 1. Step 2, write down this matrix here, which is 1, -2, 3, -4, 6, 14. Here's my step 2, and I'm going to write down everything here. Step 2, you see step 2, add. In which side? In row 2. So check what I'm going to do. Now, my second goal, step 2, it says add. So I need to convert any number on this side to what? To 0. Converting any number here to 0. I'm going to convert this number to 0. So you see, here's the 1. The change is going to be on R2. So I'm not going to do anything with R1. So I'm going to write down R1 exactly the same. Now, step 2, it says add. Here's the step 2. Check what I'm going to do. I need to get a new R2. So I'm going to say, here is my new R2. I'm going to multiply. The number here is 3. I'm going to say -3 multiply by R1. Exactly the same rule, plus R2. Let's check how much is going to be the result from this step. How are we going to do these steps? Check here. R2 is going to be R1 plus R2. Always, the second step is going to be R1 plus R2. But which number I'm going to write down here? R1 plus R2. Which number I'm going to write down here? It says R2. The first number of R2 is 3. I'm going to write down -3. I got the rule for the second step. So always you're going to write down R1 plus R2. But I have to write down the number here. How are we going to write down the number, this number here? Check the first number here on this roll. Is it 3? I'm going to write down -3. Because it says R2. That's mean I'm going to work on R2. Let's try how much is going to be the result here. Here is R2. -3 times R1, which is 1, plus R2, which is 3. -3 times 1 is going to be -3. -3 plus 3 is going to be 0. You see, the result for the first number here is 0. Let's keep going because we have to do the change for the whole row. The second R2, I'm going to say -3 times the second number here is -2 with the R1, -2 plus -4. -3 times -2 is going to be 6, because multiplying negative times negative is positive. 3 times 2 is going to be 6. 6 minus 4 is going to be 2. So the second number here is going to be 2. R2, the last number, is going to be -3 times 6 plus 14. -3 times 6 is going to be -18. -18 plus 14 is going to be -4. That means here is -4. So here's all the steps. I got the new matrix here. Check our goal. Our goal is to get this one is 0. This number, the first number with the step 1 is 1. The second number with the step 2 is 0. Then that means step 1 and step 2 is perfect. All the solution is right. We have to keep going to step 3. Step 3, it says divide. I'm going to divide any number here by exactly the same number. When it's divide, I have -4. So I'm going to divide by -4. But the first thing I have to write down the new matrix. Here is my new matrix. I'm going to write down this one here to do step 3. 1, -2, 6, 0, 2, -4. Step 3, it says divide. So I'm going to divide by the number here, because this is 0. I can't divide by 0. So I have to divide now here. This is my goal now. With the step 3, this is the goal here. Convert this number to 1. So I'm going to say I get a new R2, because I'm working on the second row. How? By dividing the old R2 by exactly the same number here, by 2. That means I'm going to get a new R2. So R1 is going to be exactly the same. 1, -2, 6, 0. Let's start with the getting a new R2. 0 divided by 2 is going to be 0. 2 divided by 2 is going to be 1. -4 divided by 2 is going to be -2. So here is the new matrix. I finished from the step 3. Why? Because my goal on step 3 is to change any number here to 1. So I convert the 2 to 1. This is step 3. One more step and you will see the whole steps, how it looks like. Step 4 is going to be on the last number here, which is going to be add. I'm going to write down the new matrix here. The new matrix is 1, -2, and here is 6, 0, 1, -2. Let's do the last step. Step 4 is add. We're going, here is the rule. I'm going to write down the rule here. Step 4. We need to convert this number to 0. That means my new step is going to be on the first row. So I'm going to get first row, a new row 1. How I'm going to do this step is going to be R2 plus R1. You see, different than the previous step. I'm not going to care about this number. You see, step 2, always I'm going to write down R1 plus R2. Step 4, I'm going to write down R2 plus R1. R2 plus R1. Now, what I'm going to write down here, I have to write down a number here. Check, this number is -2. I'm going to write down the opposite number. So I'm going to write down 2. Let's go back to the step 2. You see, step 2 is here. R1 plus R2. Which number I'm going to write down here? I have a 3. I'm going to write down -3. Step 4. R2 plus R1. Which number I'm going to write down here? I'm going to write down the opposite of this number. -2, I'm going to write down 2. Let's work on this method to get the last matrix. I need to get a new R1. That means the second row is going to be exactly the same. R1, the first number. 2 times 1. 2 times 1. 2 times 0, sorry, because 2 times R2. 2 times 0 plus R1 is 1. 2 times 0 is going to be 0 plus 1 is going to be 1. That means here is going to be 1. You see, it's exactly the same number, didn't change it. R1, now 2 times 1 plus -2. 2 times 1 plus -2. 2 times 1 is going to be 2, plus -2 is going to be 0. That means the second number is 0. One more step. R1 is going to be 2 times -2 plus this number here is 6. 2 times -2 is going to be -4 plus 6 is going to be 2. Here is going to be 2. Now check. Let's do a general conclusion about everything. One, 0, 0, 1, which is, this is my goal. By doing these steps, the 4 steps, my goal is to convert this number to 1, 0, 0, 1. You see, then these numbers change from -6 and 14 to 2 and -2. That's me. I'm just going to write down x equal 2 and y equal -2. This is my solution for this system. Again, let's do a conclusion about these. This is step 1. My goal, step 1 and the step 3, divide. Step 2 and the step 4, you're going to add. Let's go back to step 1. Step 1, convert this number to 1. How are we going to convert this number to 1? You don't have to look here. For example, you can see this one. I already know my goal is to convert this number to 1. So how am I going to convert this number to 1? I already know step 1 is divide. I'm going to divide the whole row by -1. You see, the new R1 is going to be the whole old R1 divided by -1. Step 3, I need to convert this number to 1. So I'm going to divide the whole row by 2. So step 1 and the step 3 is divide. Step 2 and the step 4, you're going to add. Let's do this one again. Step 1, convert this number to 1. So I'm going to divide the whole row by -1. So R1 is going to be the old R1 by -1. -1 divided by -1 is going to be 1. 2 divided by -1 is going to be -2. 6, -6 divided by -1 is going to be 6. This is my goal, convert -1 to 1. I'm going to write down the new matrix here to do step 2. Step 2, always you're going to write down R1 plus R2. Step 2, you have to convert this number to 0. You're going to write down R1 plus R2, always. This number is 3. I'm going to write down -3 here. Do these steps exactly here on the side. Start from the first number. 3 is going to be -3, using this rule, -3 times 1 plus 3. -3 times 1 plus 3 is going to be 0. That means this number converted to the 0. R2, the second number. -3 times -2 plus -4. -3 times -2 is going to be 6. -4 is going to be 2. Here is the second number 2. The last one, -3 times 6, -18. -18 plus 14 is going to be -4. So here is -4. I'm done from this step. I have 1, 0. I have to go to the step 3, working on this number. I already know step 3 is divide. So I'm going to divide the whole R2 by this number here, by 2. Again, we're going to write down the new matrix here. No, here, this one here, step 3. And I already know I'm going to divide everything here by 2. So here's the new rule. It says R2, the whole R2 divided by 2. The change is going to be on R2, so R1 is going to be exactly the same. 0 divided by 2 is going to be 0. 2 divided by 2 is going to be 1. -4 divided by 2 is going to be -2. So I get the new matrix. I convert this number to 1. In step 4, I'm going to write down this one here. In step 4, I need to convert this number to 0. How? It's a step 4. So always I have to keep in my mind, I'm going to write down R2 plus R1. But I need a number here. R2 plus R1. You see the opposite of this one, step 2. R2 plus R1. Which number I'm going to write down here? I'm going to write down the opposite of this number, which is step 4. -2, I'm going to write down 2. Then I'm going to do the steps on the side. So I'm not going to do mistakes. Here is the steps. This is the rule. Write down the rule. The first number, 2 times R2. So 2 times 0 plus R1. 2 times 0 is going to be 0 plus R1 is going to be 1. R2. 2 times 1 plus -2. 2 times 1 is going to be 2 plus -2 is going to be 0. That means this number is going to be 0. 2 times -2 is going to be -4 plus 6. So it's going to be 2. I convert this matrix here, this part, to 1, 0, 0, 1. I get 2 new numbers here, 2 and -4. So this is going to be the solution, x equal 2 and y equal -2. Now I need to find the solution for this matrix. The first step always is to convert. Step 1, I'm going to do step 1 here. And it says always divide. Which number I'm going to work on it? Divide all the row by this number here. So the rule, I'm going to get a new R1. How I'm going to get a new R1? By divide the old one by the first number here, which is -15. You're going to get a lot of fractions here. That's why I choose this number, this matrix Y. So you're not going to get a problem when it's a fraction. So let's start dividing. -15 divided by -15 is going to be 1. -3 divided by -15. Don't do mistakes on this part. Let's check how we're going to do this part. I'm going to bring another paper. I need to do the steps one by one. Because when you're using the calculator, it's going to be decimal. And we don't want to work with the decimals. -3 divided by -15. -3 divided by -15. It's looks like you're simplifying. Negative divided by negative is going to be positive. 3 divided by 15. Divide both sides by 3, because you're going to simplify. So it's going to be 3 divided by 3 is going to be 1. 15 divided by 3 is going to be 5. So the result is going to be 1/5. That means I have to write down here 1/5. Let's keep going. -18 divided by -15, the same thing. -18 divided by -15. Negative divided by negative is going to be positive. 18 and 15. Simplify. Divide both by 3. So it's going to be 6/5. 18 divided by 3 is 6. 15 divided by 3 is going to be 5. So I'm going to write down 6/5. So write down as a fraction. Now we're done from the step 1. I'm going to write down row 2 exactly the same. 6, 1, and 8. You see, step 1, always divide the whole row by this number here to convert this number to 1. Now let's do step 2. I'm going to write down this one here. So I can do step 2. 1 over 5 and 6 over 5. 6, 1, and 8. Write down exactly the same matrix. Now let's get the rule to get the new matrix. How I'm gonna get the rule? Always, I already know the rule here is going to be on R2, because my step 2 convert this number to 0. R2 is going to be always R1 plus R2. Always you're going to write down these two numbers here. So the rule here says R2, always I'm going to write down R1 plus R2. This is step 2. But I need to write down number here. The step 2 always converting this number to the 0. It's 6, so I'm going to write down -6 here. Write down -6 here. -6 here. Now I can use this rule. I'm going to get a new R2, so R1 is going to be exactly the same. 1 over 5, 6 over 5. Let's do this one. R2 is going to be equal -6 times R1, which is 1, plus 6. -6 times 1 is going to be -6. -6 plus 6 is going to be 0. So this number is going to be 0. With the second number, it's going to be -6 times 1 over 6. This is the important. 1 over 5 plus 1. This is important steps, how much you're gonna get. Let's do it here on the side. -6 times 1 over 5. I'm gonna do it here. -6 times 1 over 5. Put this 1 over 1. If you remember, the first section we took it is how to multiply two fractions. -6, I can write down -6 over 1. Now we're gonna multiply straight across. -6 times 1, -6. 1 times 5 is going to be 5. Now I have to add this one to 1. So I'm gonna add -6 over 5 plus 1. The result from here, you're gonna add 1. So how are we gonna add 1? You're gonna multiply by 5. Multiply this side by 5. By 5. Multiply this one by 5. And this one on the bottom is also 1. So I'm gonna multiply it by 5. So it's going to be -6 over 5 plus 5 over 5. So it's gonna be -1 over 5. So the result, -1 over 5. That's mean I'm going to write down here -1 over 5. You see, the fraction is a part of the solution. How to add and multiply fractions. Now we have to keep going. R2 is going to be -6 times 6 over 5, -6 times 6 over 5. And you're gonna add the 8. You're going to do the same thing, the same steps here. Multiply -6 times 6 is going to be -36 over 5. Add 8, the result is going to be 4 over 5. That means you're going to write down 4 over 5 here. So here is the steps. Step 2, I'm done from step 2. Now, I'm going to write down everything here to do step 3. 1, 1 over 5, and 6 over 5. 0, negative 1 over 5, and 4 over 5. Step 3, I already know is divide. You're going to divide row 2 by this number. So that means I'm gonna get new R2. How are we gonna get a new R2? By dividing the whole R2 by this number here. So it's going to be R2 divided by negative 1 over 5. So I'm going to divide the whole R2 by negative 1 over 5. That means R1 is going to be exactly the same, which is 1 over 5, and 6 over 5. Let's start. 0 divided by negative 1 over 5 is going to be 0. Negative 1 over 5 divided by negative 1 over 5 is going to be 1. 4 over 5 divided by negative 1 over 5, we have to do these steps on the side. 4 over 5 divided by negative 1 over 5. This is division between two fractions. We're gonna write down the first part, convert the division to multiplication, take the reciprocal for the second part. The reciprocal is going to be negative 5 over 1. Cancel the 5 with the 5, so it's going to be negative 4, or multiply straight across. If you don't want to cancel it, multiply straight across. Negative 4 times 5 is a 20. 5 times negative 20. 5 times 1 is going to be 5. And negative 20 divided by 5 is going to be negative 4. That means it's going to be the result here is negative 4. We're done from step 3. Now let's do step 4. Step 4, we're going to write down everything exactly the same thing here. Which is 1 over 5, 0, 1. 6 over 5, and negative 4. Always, step 4 is the opposite of this step. So R2 is going to be R1 is going to be R2 plus R1. R1 is going to be R2 plus R1. You see the opposite of these steps. Which number I'm going to write down here? Step 4 is converting this number to 0. So I'm going to write down the opposite for this number. 1 over 5, I'm going to write down negative 1 over 5 here. That means the rule is going to be R1 is going to be negative 1 over 5, R2 plus R1. I'm going to do these steps on the side, so I'm not going to do mistakes. I'm going to get a new R1. That means R2 is going to be exactly the same. 0, 1, negative 4. Now, the first number, negative 1 over 5 times 0 plus 1. Negative 1 over 5 times 0 is going to be 0, plus 1 is going to be 1. The second number, negative 1 over 5 times R2, not R1, times 1 plus 1 over 5. So negative 1 over 5 times 1 is going to be negative 1 over 5. A plus 1 over 5 is going to be 0. So here is going to be 0. Now the last number, negative 1 over 5 times negative 4 plus 6 over 5. Let's do this one. Negative 1 over 4 times negative is going to be positive. This is over 1 because we're multiplying still across. So 1 times 4 is going to be 4. 5 times 1 is going to be 5. Plus 6 over 5. 6 over 5. Now, how are we going to add these two fractions? This is steps, the whole steps is one step. We have the same denominator, so it's going to be 5. 4 plus 6 is going to be 10. 10 divided by 5 is going to be 2. That means the number here is going to be 2. You see, the fourth steps is working on this number to convert this number to 0. Now, I got to my goal, which is get 1, 0, 0, 1. That means the solution x is going to be equal to, and y equal negative 4. So this is the solution for this matrix. When you work on to find the solution of the matrix, and you do all these steps, and you arrive to a step, which is, let's do it here. You have to step here. Like you did the fourth steps, and your solution, the last matrix, is like 1, 0, 0, 0. And you're gonna find a number here and a number here. Like let's do it in numbers. 4 and 5. So sometimes, like when you're trying to find the solution for the matrix, and you reach, here is the last matrix, which is the solution. And then you're gonna write down x equal 4, but there's 0, 0 here equal 5. So if you wanna convert this one to the system, bring it back to the system. Let's bring it back to the system. So it's gonna be x, 1x, plus 0y equal 4. 0x plus 0y equal 5. If you plug in, let's focus on the second one. Plug any number here. Choose any number. There is impossible for you to choose two numbers to get the result 5. Because when you multiply 5 by this number, 0 by this number is going to be 0. Plus 0 by another number also is going to be 0. That means 0 plus 0 is never going to be equal to the 5. That's why when you have like this matrix as a result, 1, 0, 0, 0, two numbers here, you're just going to write down no solution. The same thing if you have 0, 0, 0, 1, and there is 5, 4 here. Also, you're going to write down no solution. So when you have two zeros at the same row, two zeros at the same row with the number, be careful, a number here, not a 0. A number, that means there is no solution for this system. Here is the first note. If you have like this matrix, two zeros at the same time, two zeros at the same row, you're just gonna write down there is no solution. This is the first note. The second note I'm trying to give it to you, if you have, which is exactly the same thing here, but check the first one here. I got two zeros at the same row, but there's a number here is going to be no solution. When you solve it and you find there's 2 zeros at the same row with the number, that's mean you're just gonna write down there is no solution. If you find 2 zeros at the same row with the number here, you're just gonna say there is no solution for this system.